Another job in your topographic map lab is to construct a topographic profile. This demonstration video will walk you through those steps. So here we have a topographic map from which we will construct a topo profile along the line A to B, east-west across the map. The first step in constructing a topographic profile is to label the contour lines, and so we have to find a reference elevation, and we'll use this benchmark of 982 feet and reason that the contour line that is closest to the stream is actually lower than 982 feet, and that if our contour interval on this map is 20 feet, then the lines on either side of this benchmark must correspond to that interval, and we'll label this one as 980 and label this one as 1000. And so every point in between these two lines will be an elevation between 980 feet and 1,000 feet above sea level. So now that we've got a reference point, we can follow this 980-foot contour line around the map and label it in other places and use it to leverage information on either side of it. 980 moving away from the stream plus 20 is 1,000. We're still moving uphill. I can verify that by looking at these small streams that also cross the contour lines. And the rule of V's says that when a contour line crosses a stream, a slight V is formed in the line, and the V will always point upstream or in an uphill direction. So I know that these values are increasing as I go in this direction. Can follow this 980-foot contour line to the other side of the map and label it at this point. Again, we're going uphill as we move away from the streams. For this set of contour lines, I can see a special symbol on them. These little tick marks are called hachures, and the hachures indicate that this is a closed depression. And there's a rule that you must follow when you're labeling these lines, and that is when you change direction from going uphill to downhill, you repeat the last contour line that you crossed. So this one is the repeat, 1040. Now we're going downhill, and so this innermost hachured contour is 20 feet lower, 1020 feet. This contour line is uphill of all of those, and I'm just going to write down here 1060. So I've got the contour lines labeled now along the line A to B, and so it's time to use a piece of scratch paper, slide it up to that line, and I'm going to make a mark everywhere a contour line crosses the line of profile, and then I'm going to label that. So I'll start over here. First I'll mark the margin. The first contour line that crosses it does so here, and it's the 1,040-foot contour line. At this location, 1,020 foot, the 1,000 line, the 980 line. Here is a stream, and its elevation is below 980, but not as low as 960. So I'm going to split the difference between them and just call the elevation of that stream at 970. That'll be the lowest point on the profile. Now as we move away from that main stream, we go back uphill, 1,000, 1,020, 1,040. Now we repeat that 1,040, 1,020. We repeat the 1,020 as we begin to go out of the closed depression, 1,040. And the edge of the map is at this location. Now it's time to slide our scratch paper down to the grid. I've constructed a scale on the grid that corresponds to the contour interval. I know that I'll never go any lower than 970 on the grid, so my bottom line is equal to 960, 980, and I go up to 1100 at the top. So I should be able to fit the entire profile in place. Now, what elevation did I start at? It's not right on a contour line, but it's between 1040 and 1060, so I'll estimate the starting elevation to be about 1,050 feet, and that point would be here. 1,040 then occurs directly above this point. Now, some people will slide this scratch paper up and down, and that's not a bad idea to correspond with the elevation you're working at. So this is 1020. I've got it at the 1020 line, and that's where the point goes. Drop this one down to 1,000. 980. Said my stream was going to be 970. Back to 980. Back to 1,000. Up to 1,020. 1,040. Then I repeat 1,040. We'll drop down to 1,020. Repeat 1,020. Back up to 1,040. I see that 1,040 is repeated again, and that must mean that I actually am now going downhill rather than continuing uphill. I mislabeled this elevation. It's actually not 1060. It would really be 1020. And I go off the map just before I get to the 1020 elevation, so I'll call it 1025. So I've transferred my elevations from the horizontal map surface using the labeled contour lines to scratch paper and then onto the topographic profile. So now it's time to connect these dots with the smooth line. And the resulting line then shows what the land surface would look like if you walked from the east side of the diagram at B, downhill, across the stream in the center at 970 feet. You walk back uphill, then down into a depression, out of the depression, and then back downhill again. So this method is pretty straightforward. The first step is to get your contour lines labeled. Then, using a piece of scratch paper, carefully and accurately transfer the location of the contour lines to the scratch paper, noting the elevations as you go. Slide down to your grid, construct a scale so that all of your data points will fit. Plot the points, and then connect with the line. That's it.